We're now going to develop the formulas for the half angle formulas. These formulas are based off of the double angle formulas that we've already discussed. Let's see how we develop them. What I have listed here is the formulas that we developed for sine squared, cosine squared, and tangent squared of theta. Remember, sine squared of theta is 1 minus cosine of 2 theta over 2, etc. What I'm going to do is let theta equal alpha over 2. What that gives me is sine squared of alpha over 2 equals 1 minus cosine of 2 times alpha over 2. The 2's cancel, giving me just alpha. So I get sine squared of alpha over 2 equals 1 minus cosine of alpha over 2. Cosine squared of alpha over 2 equals 1 plus cosine of alpha over 2. And tangent squared of alpha over 2 is 1 minus cosine of alpha divided by 1 plus cosine of alpha. If I take the square root of both sides of those expressions, I get the half angle formulas. Notice that we have a plus or minus in front of the radical. We use the plus or minus sign depending upon the quadrant in which the angle alpha over 2 has its terminal side. So let's do an example where we use the half angle formulas to find the exact value of a trig function. For example, we're going to find the exact value of cosine of 15 degrees. We should immediately recognize that the cosine of 15 degrees is the same as the cosine of 30 degrees over 2. So what I have here is the cosine of alpha over 2, where alpha is 30 degrees. Because the angle 15 degrees is in the first quadrant, I'm going to use the positive square root, and I get 1 plus, remember it's the cosine of alpha, so that's going to be the cosine of 30 degrees over 2. The cosine of 30 degrees, you recall, is square root of 3 over 2, so I have 1 plus the square root of 3 over 2 all over 2. What that gives me is the square root of 2 over 2 plus the square root of 3 over 2 all over 2. And that gives me 2 plus the square root of 3. Now these 2's drop to the denominator, so it's over 4. Then I get 1/2 the square root of 2 plus the square root of 3. Next, we're going to compute the sine of negative 15 degrees. Now we're going to do two things. We're not happy with the fact that we have a negative here, so what I'm going to do is use the even-odd identity and write that as negative sine of 15 degrees, which then can be written as negative sine of 30 degrees over 2. So now I have this negative sine of alpha over 2, where alpha is 30 degrees. That gives me negative square root of 1 minus cosine of 30 degrees over 2. Remember the half angle formula for the sine. So I have negative square root of 1 minus cosine of 30 degrees is square root of 3 over 2 over 2. And by the way, you might be wondering, how did you know to take the negative square root? I'm taking the negative square root because the terminal side of my angle is in the fourth quadrant where the sine function is negative. Finally, we're going to have, let's see, this is going to simplify a lot like this guy did. It'll eventually turn out to be the negative 1/2, again that negative, and then we're going to get square root of 2 minus the square root of 3. The simplification process works just like the one up here, only it's a minus instead of a plus. So hopefully that doesn't cause any confusion.